A device runs until either of two components fail, at which point the device stops running. The joint density function of the lifetimes of the two components is given here. Find the probability that the device fails during the first hour of operation. So what they're trying to say here is that both the components have to run in order for the device to keep running. Even if one of the component fails, then the device fails. So to find the probability that it fails during the first hour, if you try to do it directly, you will say that, okay, that will happen. The failure during the first hour will happen if the first component fails, or the second component fails, or both component fails. So actually, if you do it this way, in the direct way, you have to do 3 double integrals. So the shorter way of doing it is to do it through the complement. So you first calculate the probability that it runs for at least 1 hour. So you see, running for at least 1 hour is the complement of failing during the first hour. So it will run for at least 1 hour if both the components run for at least 1 hour. It means both the components run from somewhere between 1 and 2, because the lifetime is between 0 and 2. And so running for at least 1 hour means running from 1 to 2. So with this double integral, and for those of you who haven't seen double integration, it's pretty easy. What you do is you first do this inside integral. So the inside variable is x. So now when you do this integration, x is your variable and treat y as a constant. So I can pull the 1/8 out, and then I just have x plus y, and I'm doing it with respect to x. So the integral of x is x squared by 2. And since y is a constant, so the integral of y with respect to x is just y times x. And right now I did it with respect to x. So the limits will be from x equals 1 to x equals 2. These limits 1 to 2. So the dx is the inner variable. So the inner limits correspond to x, and the outer variable is y. And so these outer limits correspond to y. So now when I substitute x equals 2, it's 2 squared over 2, which is 2. And then x equals 2 here gives me 2y, so 2 plus 2y, and then minus the lower limit, x is 1, so 1 by 2 plus y. And this simplifies to 3 by 2 plus y. And now I'm back to just the one variable integral. So I integrated like this is 3y by 2 plus y squared by 2, put in the limits. Eventually I get 0.375. And so that was the device running for at least 1 hour. So the probability that it runs for less than 1 hour will be the complement of that. So that's 0.625, which is choice D.